Welcome back, geometry folks. We are going to be talking about radical scale review still, and this is our second topic on adding and subtracting radicals. So what you'll need for this video is a pen, pencil, calculator, and your notes. Remember, you only have to write down the slides that have the pencil in the top right-hand corner, so you do not need to write this slide down. But this is our basic understanding of this idea of adding and subtracting radicals. So if we had 3 pencils plus 2 more pencils, or crayons I should say, then we'd have a total of 5, right? The crayons are this thing and this thing are like terms, if you will. If we had 3 apples and 2 oranges, there's no way we can combine those 2 fruits because they're not the same. So keep that in mind as we continue today. With this same idea, in order to add or subtract radicals, you must have like radicals or like terms. So like radicals would be the square root of 3 plus 4 times the square root of 3. The square root of 3, this number under the radicand, is the same, and that's what we mean by like radicals. So this would be an example where we combine this to 5 times the square root of 3. Or if we had 2 times the square root of 5 minus 3 times the square root of 5, those are like radicals. 4 times the square root of 7 plus 3 times the square root of 7. And finally, our last example is negative 2 times the square root of 10 plus 5 times the square root of 10. These are all like radicals. And again, you do not need to write this slide down. So if we're talking unlike radicals, we would have the square root of 3 plus 4 times the square root of 5. Those are not the same numbers. This 3 under the square root and this 5 under the square root are not the same, so we can't combine them. This would be another example, and these would be more examples. So 2 times square root of 2 minus 5 times square root of 3, square root of 30 plus 4 root 13, root 20 plus root 12. Those are all not like radicals, so we can't combine them. So let's do some examples. Maybe this will be more easy for you to understand. For this first one, make sure you write these in your notes. We have the square root of 3 plus 2 times the square root of 3. Just like as if we were adding a variable. If we had x plus 2x, we could condense that into 3x, right? So now instead of saying we have x, we have the square root of 3. So if we have 1 times the square root of 3 plus 2 times the square root of 3, that's going to give me a total of 3 roots of 3. Okay, now number 2, we're saying 3 times the square root of 5 minus 2 times the square root of 5. We have 3 roots of 5 and we're taking away 2 of them. That will leave me with 1 times the square root of 5, and you really don't have to put the 1 in front of it. The most correct or simplified form would just be root 5. And then last but not least, let's check first. We have 3 radical signs going on. If all of them are like radicals, we have 3 times the square root of 7 plus the square root of 2. So 2 and 7 are not like radicals, but we can combine the 3 times the square root of 7 and the 5 times the square root of 7. So the most we can simplify this one is into 2 terms rather than 3. So we have to look at 3 times the square root of 7 plus 5 times the square root of 7. If we have 3 roots of 7 and 5, add that together, that'll give us 8 roots of 7. And then we can't condense the square root of 2, so we just have to leave that as a plus square root of 2. Okay, so those last 3 examples were easy to combine because the radicals were already simplified. Now we're going to look at 2 examples where our radicals are not in the simplified form. The square root of 8 can be reduced, right? Remember our perfect squares, it's 1, 4, 9, 16, 25, all those great things. Well, 8 is a factor of 4 and 2. So we can split that into the square root of 4 times the square root of 2. And the square root of 4 breaks down to 2 times the square root of 2, right? And we can also take out a square root of 4 and a square root of 3 out of the square root of 12 because 12 has factors of 4 and 3 and 4 is a perfect root. So square root of 4 is 2 and we still bring down that square root of 3. We can't reduce that. So now we have 2 times the square root of 2 minus 2 times the square root of 3. We don't have like roots. This is the square root of 2 and the square root of 3. So that can't be reduced, but in order to say that the square root of 8 minus the square root of 12 is in the most simplified form, we have to reduce or split the square root of 8 and the square root of 12 separately to say that it's in the most simplified form. So now let's look at the square root of 18 minus the square root of 2. 18 has lots of different factors, like 3 and 6, but 3 and 6 and 1 and 18, none of those four numbers are perfect squares. But 9 and 2, 9's a perfect square, so we can split 18 into the square root of 9 times the square root of 2. And then we still have this minus square root of 2, because we can't simplify the square root of 2. That's already as condensed as it can go, or simplified as it can go. Square root of 9 is 3 times the square root of 2 minus the square root of 2. Now if we look at our radicals, we have the square root of 2 and the square root of 2 in the first and second term. So those are like radicals. So we're saying 3 roots of 2 minus 1 root of 2 will get us to 2 roots of 2. So in that case, we can subtract the 2 because they do have like radicals. The first one we couldn't. So that's where we had to leave it. So make sure to get this summary in your notes. So we have two main points for today's lesson. In order to add or subtract, you must have like radicals. So make sure you get that first point in your notes, and then also we must simplify the radicals and then try to add or subtract. Some may already be simplified as much as they can be, and then other times we'll have to simplify first and then combine like radicals.
Thank you for taking such good notes today. In addition to this short video, you're going to have 10 practice problems from Classroom. So there's 10 problems posted on Classroom, and you should do them on a separate sheet of paper to turn in the next time that I see you. So in addition to this video, make sure you get those 10 practice problems, and even if you want to just do them in your notebook, you don't have to turn them in. Just want to make sure that we practice what we saw in this video, and I shall see you soon.